Hi everybody, welcome to lesson 2.5 where we're going to be exploring square roots. Our goal for today is that we can recognize and calculate perfect squares and non-perfect squares. First of all, you are going to need a calculator for this, so I want you to find your calculator and we're going to find the square root symbol. Do you see right above the x squared, do you see a little square root symbol right there that's written on the calculator? Yeah, to get that symbol, we'd have to type in the second function. Oh, maybe I should turn it on first. The second function of the x squared button, and that's going to give you a little square root symbol just like that. Then you could type in the number 25 and hit enter and it will tell you 5 because 5 times 5 is 25. So you want to find your second button and then the x squared right above it is the square root symbol. Okay? All right, so to start us off, we're going to look at some perfect square roots. A perfect square root is one in which you're going to get a whole number answer or a terminating decimal answer. In this case, today we're just going to look at whole number answers. So we've got the square root of 1 is 1 because 1 times 1 is 1. The square root of 4 is 2 because 2 times 2 is 4. The square root of 9 is 3 because 3 times 3 is 9. And the square root of 16 is 4 because 4 times 4 is 16. So now, what's the square root of 25? We just did that on the calculator and we got 5 because 5 times 5 is 25. What I'd like you to do is to pause the video and I want you to fill in all the square roots all the way up to the square root of 225. Practice using that key on your calculator to do it. All right, go ahead and check with mine. How did you do? If you need to pause the video to fill them in because you don't have a calculator, that's fine, but you definitely need to get a calculator so that you can learn how to use the buttons on your calculator. All right, now that we have all the perfect square roots, let's start to take a look at square roots that are not perfect. Like, for instance, the square root of 45. Now, I'm going to kind of pull this little cool piece of paper I have out here that has all those perfect square roots on there. And we're going to take a look at square root of 45. That's not a perfect square root. It's not going to make a whole number. But take a look at the square roots that we do know make whole numbers. Which two is it in between? Square root of 45. Wouldn't that be in between the square root of 36 and the square root of 49? Yeah, because this square root falls in between these two right here. We know that it's the number for the square root of 45 has got to be in between 6 and 7. So right here on our chart, we know that the square root of 45 is going to be in between the integers 6 and 7. Well, let's use our calculator to round to the nearest hundredth. Because the square root of 45 is not a perfect square root, it's going to have a decimal that goes on forever and ever and ever past the calculator screen even. Forever, just like pi. Okay, so we're going to round to the nearest tenth. So one decimal place, 7. Taking a look at the next number, it's not going to bump it up, just 6.7. All right, now let's circle the integer that it's closest to. 6.7, would that be closer to 6 or 7? Yeah, you've got it, closer to 7. Okay, let's look at the next one, negative square root of 30. Okay, this is still just the square root of 30. It's just that it happens to be on the opposite side of the number line from the positive numbers. It's a negative number. So let's just look at the square root of 30 and compare it to our chart of square roots that we know the exact answer to. Where would it fall in between? Yeah, these two, right? Square root of 30 would be in between the square root of 25 and the square root of 36, meaning that it would be in between the numbers 5 and 6. But hold on, negative. It'd be in between the numbers negative 5 and negative 6. Okay, so let's write that down. It's in between the integers, negative 5 and negative 6 on the number line. Now let's type it in our calculator. All right, so down here at the bottom, I've got my negative sign. So negative, that's going to give me the negative. Now I'm going to do second function of that x squared button, and I'm going to type in 30 and enter. Ah, see? Negative 5 point. Now we want to go tenths place, 4, but look at the number after it. It's a 7, so that's going to bump that up to a 5. Negative 5.5. Oh, I'm sorry. You know what? The directions actually say round to the nearest hundredth. Oops. All right, we better follow the directions. Hundredths. Okay, so we're start over. Negative 5 point. Okay, so we got 4, 7. The 4 stays. It's in the tens place. Now the 7 in the hundredths place. Look one decimal place after it. It's a 7. That's going to bump that up to an 8. There we go. Much better. Okay, now is this closer to -5 or -6? Oh, it's not even quite 5.5, is it? So it definitely is going to be closer to -5. We're going to circle that -5. Now, I wouldn't have needed to type the negative in my calculator. I could have just done square root of 30 and got that, and then just put a negative sign in front of it. That would work too. Okay, this next one, square root of 3.43. Oh boy. Let's pull our chart back out here. Square root of 3.43. What two square roots would that be in between? Well, I think square root of 1 and square root of 4. Wouldn't it be right in between there? The square root of 3.43? Yeah. So that means that the value of this is going to be in between 1 and 2. All right, so in between 1 and 2. Let's use our calculator to actually find the value of this. So second function, square root, got the square root key on there. And we're going to type in 3.43 equals 1.85, and the 5 gets to stay a 5 because the next digit's a 2. 1.85. Now see how the decimal goes forever across the calculator? It's going to do that. When it's not a perfect square root like these ones are, then the decimal is going to go on forever. We call that an irrational number. Irrational. Okay, so we're definitely closest to the number 2. There we go. So we can use our calculator to help us find the value of perfect square roots, and we can use our calculator to help us find the value of non-perfect square roots. And that's where we're going to get a decimal that goes across our calculator forever, and we're going to need to round that. All right, on the next page, if you see this question here, how do we find the side length of a square if we're given its area? Before we actually start this application problem, let's take a look at a couple examples where if I give you a square with its area, you can figure out what the side length of the square is. So just over here in our notes, I'm just going to draw a perfect square, and I'm going to tell you that the area is 64, let's just say, feet squared. Well, how are you going to find the side lengths of that square? We know to find the area, we have to take length times width. How would we find the side lengths? You know what it is, right? You know it's 8. Absolutely. You know what we would have to do? We'd have to take the square root of 64. And the square root of 64 equals 8. Therefore, the side lengths of the square are 8. Let's try another one. We'll make this one purple. Let's say I gave you a bigger square, and I told you the area was 121 inches squared. And I wanted to know the side lengths that make that square. Well, what would you do? How would you figure out what number times itself gives you 121? Yes, the square root of 121. So if you type that in your calculator, or you just use your notes here, we see that's 11. So we would have an 11 by 11 square. 11 times 11 is 121. Okay, so this is how we would find the side lengths of a square if we're given the area. We use the square root button on our calculator. Okay, now let's take a look at the application. You want to create a square garden and fill it with flower seeds. The seed package says it will cover 115 square feet. What is the largest garden that you can create? So let's circle the question here. What is the largest garden that you can create? Remember, we want it to be square. So to put our answer, we're going to say here the dimensions for my garden need to be blank feet by blank feet. Period. All right, let's figure it out. Let's figure out what those dimensions need to be. All right, we've got the area of our garden is 115 square feet. I can have 115 square feet area. That's how much my seed package is going to cover. So what could the dimensions be? What number times itself gives me 115? How can I figure that out? Well, you are absolutely right. We want to take the square root of 115. That's going to tell us what number times itself gives us 115, just like we did over here with these two examples right here. So I know that 115 is not on my chart, square root of 115. It's actually in between these two square roots. So we know we're going to get an answer in between 10 and 11 when we use the calculator. It's not going to be a perfect square root. So square root of 115. Ooh, see how it goes all the way across the calculator? That's because this is an irrational number. Approximately says that we want to round to the nearest tenth. So approximately 10.7, and that's going to be feet. Okay, so the dimensions of my garden could be about 10.7 feet by 10.7 feet. Now let's just check that. Now remember, we round it. So if I say that this is about 10.7 feet on this side and this is 10.7 feet on this side, we're going to get really close to 115. 10.7 times 10.7, length times width. Look at how close we got to 115. Remember, it's not going to be exact because we rounded this value, but it's really, really close. So I could have a 10.7 foot garden by 10.7 feet, and then that's going to be able to have all of my seed package in there. All right. Thank you so much for joining me for lesson 2.5 on square roots. Hopefully you can tell the difference between a perfect square root and a non-perfect square root. Feel free to use your calculator on anything, and good luck. Have a great day.